Good morning, y'all. Castro here, coming to you from my backyard, and I wanted to give you a little question about the force created by projectiles. So I came up with this idea when I got this pellet gun, and I wanted to figure out the force that it's generating. So in order to figure out force, we need to know a couple things. We need to know how fast it's accelerating, and we need to know the mass of the projectile. So let's go ahead and see if we can come in here and get a speed, a velocity with the chronograph. This is going to be in feet per second. Okay, 1,097 feet per second. Can you see that? So my speed in a given direction is going to be velocity, and it's going straight, is 1,097 feet per second. Let's see if I got another marker that'll work with my kids' whiteboard set. 97 feet per second. So there's my speed. Now, I know the speed, the distance between me and the chronograph, let's just say it was 1 foot. That's how far away I was when I was measuring the speed. And what I don't know is how long it took to cross that distance. So I need to figure out time. Time's my unknown. Now, the cool thing about speed, distance, and time, as you guys know, is there's a cheater triangle for it. And I love these cheater triangles, and they show up all the time in science and math. So if I want to solve for speed, I cover the speed and I get distance divided by time. If I want to solve for time, I cover the t and I'm left with d over s. So my formula is t equals distance over speed. So my distance was 1 foot divided by 1,097 feet per second. Gonna have to do a little calculating here. Okay. Come on in here, can you see this? So I have 1 foot divided by 1,097 feet per second equals 0.000911. So let's use that. 0.000, let's just say 91 to make it a little shorter. And if I have feet divided by feet, I know those feet are going to cancel out. My unit I'm left with is seconds. That's a unit of time. I'm solving for time, so I know that it's correct so far. So now I got my time, and I can begin to solve for force. So if you remember, Newton's second law states force is equal to mass times acceleration. And again, we have another cheater triangle for this. So force is equal to mass times acceleration. Same thing, if I wanted to solve for the mass and I knew the force and acceleration of a projectile, I could figure it out by force divided by acceleration. Same thing with acceleration, force divided by mass. But I want force. So I know force is equal to mass times acceleration. It's actually a small a, but. So my mass, I know how big my projectile is. My projectile is 7.2 grains. When we were using projectiles, they use grains measurement. It's an old style measurement. What it really means is the mass is equal to 0.466 grams. And that's equal to 7.2 grains. So I know my mass. I prefer this to be in kilograms because I know my mass needs to be in kilograms and my acceleration needs to be in meters per second in order to get newtons, which is what I want you to solve for. But I'm just going to leave it in grams. It'd be very simple to change this into kilograms and just move it 3 places to the left. but the force calculator I gave you online is going to make it very simple, and we can use grams. It's just fine. So we have the mass, we need the acceleration now. Now the acceleration, to solve for acceleration, if you remember, it's VF minus VI divided by time. So I know my final velocity was the speed I got from the chronograph, 1,097 feet per second, minus initial velocity. It wasn't moving, it was stuck at the end of the barrel at 0 feet per second, divided by my time, which I already solved for at the beginning. T is equal to D divided by S, and I got 0.00091 seconds. So I know 1,097 feet per second minus 0 seconds is just going to be 1,097 feet per second. So I can take my calculator, clear it, can you see? So I have 1,097 feet per second divided by 0.00091 seconds equals, my acceleration is really fast, 1,205,494.51, and that is feet per second, feet per second squared. So I know it's an acceleration unit because my time is squared. Now I can solve for force. Force is equal to mass, which is 0.466 grams, times my acceleration of 1,205,494.51 feet per second squared. Now I can't multiply these straight across because I don't have it in kilograms or in meters per second. But fortunately for you guys, I gave you this force calculator. So it's in calculator soup, and you'll just go to, you're calculating for force. We want to solve in newtons. The mass is in grams. So I'm going to set it in grams. And my mass is 0.466 grams. The acceleration is 1,205,494.51, and that's feet per second squared. Now I can calculate it, and there's my answer, 171.225 newtons. So force is equal to 171.225 newtons. That's quite a bit of newtons. It's a very fast projectile. It's very lightweight. Just for a comparison, I looked it up. A flick is about 6 newtons of force. So this is quite a bit of force generated. You all are going to do the same thing, solving for the force created by a 7.9 grain projectile and a 9.8 grain projectile. I also gave you guys a calculator to convert grains into grams for each of those grain weights, and all your numbers will be online for you. Go ahead and go online, and you guys can come back, replay this video if you had any questions about how to solve those. Show me your work. Make sure you guys have fun and stay safe. Castro, signing out.